Titan is the name given to the largest moon of Saturn as an homage to the mythical Titans, who were the siblings of the Roman deity Saturn. Titan the moon is an extremely interesting place. As you'll soon find out, it simultaneously shares many features with other moons and planets in the solar system, but it also retains a very distinct, unique alienness about it. For example, Titan is similar to Enceladus and Europa in the sense that they all have subsurface liquid water oceans. Under the ice on Enceladus and Europa, the oceans are composed of very salty water. But on Titan, the deep subsurface oceans are a mixture of liquid water and ammonia, which acts as a kind of antifreeze. In all of these moons, the subsurface ocean is global, which means that the surface material is completely disconnected from the core and rotates independently of it. The core and the crust, therefore, respond differently to the gravity fields and the tidal forces of their surroundings. Enceladus and Europa both have icy crusts that frequently crack and shift in response to these tidal forces. But this isn't the case with Titan. Titan appears to have a much more rigid crust that's a lot less susceptible to fracturing and warping under tidal forces. This means that Titan doesn't really have that much tectonic activity. It doesn't have earthquakes, and while it does have mountains, they aren't very large, and they seem to have mostly been formed through upwelling of fluid material under the surface, like a bulge that leads to a volcano. Most of the surface of Titan is young and smooth, the result of wind and liquid methane eroding the soil and washing loose material into basins and depressions. A prime example of Titan's uniqueness is its atmosphere. Titan is the only moon in the solar system with a major atmosphere. Other moons have faint wisps of gas hovering over their surface, if they have any atmosphere at all. But Titan has a relatively thick atmosphere, composed of nitrogen, methane, and hydrocarbons. Titan's atmosphere is unique among the solar system's moons, but in some respects, it's remarkably similar to Earth's atmosphere. Like Earth, the predominant gas in Titan's atmosphere is nitrogen. Titan just has proportionately more of it in the atmosphere than Earth does. Titan also distinguishes itself by having a lot of methane and larger hydrocarbons floating around in the air. The methane in the upper atmosphere is broken down by UV radiation, producing carbon-containing radicals that can react with each other to form larger hydrocarbons. These hydrocarbons include ethane, propane, propene, acetylene, diacetylene, methylacetylene, cyanoacetylene, hydrogen cyanide, and cyanogen, among many others. And these together make up a small percent of the atmosphere by volume, but they contribute greatly to the atmosphere's murkiness and opacity. Now, it's pretty interesting that there's a sizable quantity of methane in Titan's atmosphere, because UV radiation from the sun would normally break that methane down relatively quickly. For example, the amount of methane in Titan's atmosphere right now, if it wasn't to be replenished, should be fully decayed within about 50 million years, which, when you're talking about the lifespan of the solar system, is a relatively short period of time. But because there's this persistent presence of methane in the atmosphere, this means that there must be some process on Titan that's actively producing methane and counteracting the natural rate of decay. Considering the quantity of methane that would have to be produced, it's probably being pumped into the air by cryovolcanoes that bring methane up from beneath the icy surface. It's possible, however, that at least some of this methane could be produced by methanogenic life forms. Now, speaking of cryovolcanoes, there's evidence hinting at their existence, but I don't think that it's been confirmed yet. It's estimated that there's cryovolcanoes on Titan that release plumes of liquid water and ammonia. This water-ammonia solution composes the subsurface ocean, and when high pressure meets a weak point, the fluid pushes up to the surface and erupts in massive plumes that can blast 200 meters into the air. Now, going back to the comparison with Earth, the atmospheric pressures on Titan and the Earth are remarkably similar. Titan has a slightly higher atmospheric pressure, but it's well within a range that a human would find comfortable. I mean this only in the sense that the pressure would be comfortable. the temperature would be very, very uncomfortable. Titan is extremely cold, with an average surface temperature around 94 Kelvin, or 180 degrees Celsius below freezing. It's so cold partly because of its distance from the sun, which means that it only gets 1% of the light that Earth gets, and also partly because of its thick, tholin-filled atmosphere, which absorbs all of the incoming heat in the upper layers. On Earth, enough heat makes it through the atmosphere to reach the planet's surface, which makes the surface of the Earth comfortable and fertile for life. But on Titan, because there's all these tholins in the atmosphere, they block 99.9% of the heat from reaching the surface. If it weren't for the methane in the atmosphere behaving as a greenhouse gas, Titan's surface would be way colder. Now, this is where things on Titan start to get really, really cool and really interesting. So on Earth, the temperature and the pressure is just right for water to exist in all three phases. Earth has water vapor in the atmosphere, which forms clouds, which can then condense into rain, which falls upon the land and creates lakes and rivers, which erode the landscape and shape the terrain. On Titan, it's much too cold for water to exist in multiple phases. The vast bulk of the water on the surface of Titan is locked up in the crust as ice, and just trace amounts of water vapor lingers in the upper atmosphere. It's far too cold for liquid water to exist anywhere on the surface. It can only exist with the ammonia antifreeze deep underneath the surface, much closer to the core. So while Titan's surface is far too cold for liquid water to exist, it just so happens to be perfect for methane. On Titan, methane exists in three phases. Methane forms clouds in Titan's atmosphere, which freezes into methane snow, or it condenses into methane rain, which cascades down onto the land to form methane lakes and methane rivers, which erode the landscape just like water does on Earth. On most other moons and planets, like Mars for example, the rocks are jagged and sharp because there's nothing that can erode them anymore. Mars's water and atmosphere have long since gone away, so when a rock falls down a cliff and breaks, it'll stay ragged and jagged for millions of years. Conversely, on Venus, where the atmosphere is extremely dense and violent, all of the surface rocks have been brutally eroded down into flat, slate-like shapes. Now on Titan, we've only had a few images from the surface, but the pictures we do have shown a bunch of round rocks, like river rocks. All of these round rocks have been eroded by liquid methane, flowing in the form of rivers and lakes, and in the currents and waves of methane oceans. Besides the Earth, Titan is the only other body in the entire solar system where there's stable, long-lasting lakes on the surface. These methane lakes on Titan look just like Earth lakes from satellite images, and the largest one is so big that it actually covers more surface area than Lake Superior. These methane lakes on the surface of Titan are potential hotspots for alien life. I mean, Titan itself is a potential hotspot for alien life. It might have more potential for life than any other planet or moon in the entire solar system besides the Earth. Consider the atmosphere. There have been numerous experiments that have recreated the gas content of Titan's atmosphere and stimulated the gases with UV light and electric pulses. This leads to the genesis of organic molecules, including all 5 nucleotide bases and amino acids. These experiments have demonstrated that all of the major building blocks of life can be generated, and they can exist in the atmospheric environment of Titan. There's other chemicals in the atmosphere that are also indicative of life, or at the very least, their existence on Titan suggests that it's much friendlier for life. For example, hydrogen cycles through the atmosphere, and hydrogen can be consumed by methanogenic microbes to produce energy. Complex organic chemicals, like polycyclic aromatic hydrocarbons, have been detected in Titan's upper atmosphere, which demonstrates that biochemistry on Titan can develop larger, more complex molecules than just the basic building blocks. In the upper atmosphere, chemical reactions form large quantities of hydrogen cyanide. The hydrogen cyanide descends down through the atmosphere to reach the surface. But surprisingly, the actual concentration of hydrogen cyanide on the surface is really, really low. This raises a question. Where is all of this hydrogen cyanide that's falling from the sky? Where is it going? It would seem that some process happening on the surface of Titan is consuming all of that hydrogen cyanide. But what could that process be? Scientists don't know. It's likely to be some kind of geological process, but it's also entirely possible that it's some kind of organism consuming the hydrogen cyanide through a biological process. The hydrogen cyanide can also polymerize to form a chemical called polyamine, which might be conducive to biotic cryochemistry, or biotic chemistry that takes place in extremely low temperatures. There's also a chemical called acrylonitrile, or vinyl cyanide, which could theoretically form cellular membranes in a supercold methane or ethane solution. The acrylonitrile can spontaneously form sheets, which can then form bubbles and vesicles. Despite being very cold, the membranes retain flexibility while remaining stable. If life exists on Titan, it could have vinyl cyanide composing its membranes, as opposed to life on Earth, which uses phospholipids in a water solution to create membranes. It really seems as if Titan has everything that life needs to survive, and indeed, Titan is considered to be the most habitable place in the solar system besides the Earth. If there's potential for life anywhere in the solar system outside the watery surface of the Earth, it's on Titan. Where life on Earth has phospholipid membranes and inhales oxygen and metabolizes glucose for energy and exhales carbon dioxide as waste, it's quite likely that any potential life on Titan would have acrylonitrile membranes, and it would inhale molecular hydrogen, it would metabolize acetylene, and it would exhale gaseous methane. The idea has been tossed around that if life exists on Titan, it might be the product of panspermia from Earth. While I suppose that this is arguably within the realm of possibility, it's considered extremely unlikely, because the early Earth life would not have been able to adapt to the Titan environment. The cold temperatures and the lack of liquid water would have presumably been impassable barriers. If there is life on Titan, and it didn't originate from panspermia from Earth, then it would most likely have undergone its very own genesis event, which has big implications for the possibility of life elsewhere in the universe. It's also possible that over the next 5 billion years, as the sun expands, Titan will be warmed up to the point where liquid water can exist on its surface. At this point in the sun's lifetime, it'll also be producing a lot less ultraviolet radiation, which will stop breaking down the methane in Titan's atmosphere, which will mean that the hydrocarbons will thin out, and the orange fog in the atmosphere will clear. More sunlight will be able to reach Titan's surface, and this will warm up the moon. This suggests that in the far future, Titan will perhaps become the most habitable place in the solar system, at least for a brief window of a few 100 million years. Titan is really similar to the early prebiotic Earth, maybe a little bit colder, but ultimately, over the next few billion years, it could quite possibly develop the near-perfect conditions necessary to generate and sustain complex life. Thus, as the sun matured and enlarged, the living soul of the solar system would transition from the Earth to Titan. As fascinating as all of this chemical conjecture is, until we send probes, or better yet some people, down to the icy surface of Titan to take a look around, all of this potential life is just that. Potential.